Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, today we will discuss about one of the most frequently asked interview questions, which is repartition and coalesce and differences in Spark. So repartition is a wide dependency transformation in Spark, and this Spark data frame API allows you to repartition the data frame. So this is the function used for repartitioning the data, and in the repartition there are two methods which we use, which is the repartition, df.repartition with the repartitions and the columns, and in this minimum one parameter is required. Okay, both like two parameters it will take, but one is minimum required. And second one is repartition by range, which means that it will do the repartition by range of the numbers in the data, and it also takes two parameters, num repartitions and columns, any number of columns you can mention on which you wanted to do the repartition. And even in this function one input parameter is mandatory. Okay, so this why we have to do repartition is by default Spark has the mechanism to take care of the partitions of the data that you are using as input, and it can provide you all the required functionality for partitioning the data. But sometimes what will happen is, due to some data skewness or due to some other issues, you might notice that the partitions are not properly done by Spark, and you wanted to have your own partitions for the data that you are dealing with. For such kind of reason we use repartition option. But if it is necessary only, if you have proper reason, then only use repartition. Otherwise please leave it to Spark, it will take care. Okay, so now we have two functions here, right? One is repartition and other one is repartition by range. So these two are both are same, but except one functionality is like this repartition, right? The first first function repartition, it uses hash based partitioning. So when it is partitioning the data, it uses the hash based partitioning. And this second one, which is repartition by range, right, it uses the range of the values based on the partitions. Like for example 0 to 5 numbers, it will go to first partition, 6 to 10 goes to the second partition, etc. Okay, and in both the cases, right, it will take two parameters, but minimum one is mandatory. Okay, so for this reason, how we can call this this repartition, right? How we can call is, let's say you have a data frame dot repartition of 5. When you say this way, it will consider that we have to do the five repartitions. We have to convert, like we have to make 5 partitions of the data. For example, let's think this is the worker node and you have some data in it, and when you say repartition of 5, it will create 5 equal sized uniform partitions. How many number you provide here, right, in the num partition, it will split the data to 5 partitions. Okay, it will create 5 partitions because we are giving 5 here, but all the equally sized partitions. And also if you wanted to partition based on a column, let's say DEPT number, on the department number you wanted to do the column, because in a, like, let's imagine one employee database, multiple employees fall under a single department number, right? I mean, you will have multiple department numbers as well, but under one department number you have multiple employees, and you wanted to see analyze some data based on the departments. In such case, you can do partition on this column. If there is a column like this is the column name. Okay, so what you can do is you can pass the column name like this. in the repartition function. And you can pass multiple columns as well. Okay, for example 5 comma you wanted to do department number, and again you wanted to, let's say, some salary. Okay, I am simply taking some random columns. It shouldn't be the same, it will differ based on your requirement. Okay, so you can send one or more columns as input parameters as well. Okay, and let's say you don't know how many number of partitions you need to do, but you want the partition to be done on department number, right? In such case you can send only the department number, and maybe some date you wanted to do, right? So then let's say some date, some emp date, some date column, and department number. On all these, on both of these columns, if you wanted to do the repartition, you can do. So you can, we should send one parameter minimum required. So anything you can send. You can send the number of partitions. If you don't know how many number of partitions you have to do, then you mention on the column. Okay, and then and also like if you wanted to see the, like, I don't have the setup of Spark UI, so that's why I couldn't show you these things. But if you are trying for this, right, you just cache it, create a data frame with some range or something, df.range or something, then you repartition that, and repartition, let's say for 10, and do cache. So what cache will do is, it will show us in the UI, right, how the partitions are done, like divided. Okay, that you can see when you do the cache in the Spark UI. Okay, and so as I said, all the partitions will be uniformed, so same memory size will be allocated. Okay, and also this whatever number of partitions that we are sending, right, first we can, instead of repartition, we can also send through the Spark SQL shuffle configuration. So we have this configuration, right? So there also we can send shuffle partitions, how many we need, number of partitions we need, we can send that as well. So first configuration will be considered. If it's already there in the configuration, means we will set it up, right, while sending the Spark submit command or something. So you can send the configuration there, and also along with that, like if you don't want that and you wanted to override that configuration that you are sending in the Spark submit command or in conf file, then this will be considered. Okay, so first it will take the configuration file only as per the configuration, and if you explicitly mentioned like this in the code, then it will consider whatever you are sending in this code. Okay, and next one is, for example, here when I say you equally sized partitions, right, when you say 5 equal sized partitions will be created, but let's say if you are partitioning based on the department number, and department 1 will have 10 employees, department 2 will have 100 employees, so department 3 will have 150 employees. So if you can see, it will not be able to create the equal sized partitions. So because of the data difference, the records difference in these partitions, when you do partition by department number, so the partitions that will be created will be like ununiformed. Okay, it will not be uniform because we don't know the size of the data under each department number, right? So that one we have to take care. So when we summarize the details about this repartition, right, so repartition creates uniform size of the partition of data, and also along with the number of repartition number, right, we can also send one or more columns as input to the repartition function. And also this repartition by range will make the partitions based on the range, like department numbers 1 to 10 will go to one partition, 11 to 20 will go to one partition, something like that. It will divide when you do by range. Okay, repartition by range. And also when you repartition based on this column, right, we cannot guarantee on the size of the partition. I mean uniformity we cannot guarantee on that. And also important thing to notice is repartition causes shuffle sort. Okay, and the number of output partitions are depend on the shuffle partition configuration. and also but this configuration will be override based on whatever we send in the code. But just remember that don't use the repartition without a proper reason, because it causes shuffle, so which will impact on the Spark job performance. So actually when we have to do the repartition means, let's say you have to use some data repeatedly, or you have some filters on some particular columns, like even though you have department numbers 100, but you are like your main job has the data like a code to perform only on some filters, right? Then you can use the repartition on based on that filter column, so that the filters will be faster. And also another scenario, like the data is partitioned well for some reason, right? Then you can do the repartition to just reduce some data skewness or something like that. Okay, so other than that, it's not advised to use repartition because it creates shuffles. And now let's say initially you have created 5 and now you are increasing to 10, right? Then use repartition. Then what is the second one is coalesce. So coalesce also does the same thing, like it's similar to repartition, and it will take one parameter which is the number of repartitions. But what coalesce will do is, if you wanted to decrease the number of partitions, then use the coalesce. Why is it like? Even if you use coalesce for increasing the repartitions, the partition numbers, right, it will not do anything. It will just like statement cannot be like executed something. Okay, it's like a not very useful statement. So whenever you have a requirement to decrease the number of partitions for some reason, right, based on some data skewness or something, then use coalesce. If you have to increase the number of partitions, then use the repartition. So why we have to use coalesce for only reducing is this coalesce operation, right? This coalesce transformation. For example, you have a cluster with 5 worker nodes. Okay, let's say 5 nodes, and the first worker node divided into two partitions, and here the second worker node has 2 partitions, third worker node has 1 partition, fourth worker node has 1 partition, and fifth worker node has 2 partitions. Just imagine this way. So we have 5 worker nodes, 8 partitions. Now when you do df dot coalesce of 5, let's say here 8 partitions are there, so you are reducing it to 5. What coalesce will do is, it will not generate any shuffle or sort, but it will just combine the local partitions. Means these two whatever were there in this one, right, it will make it to 1, then these two will make it to 1, this anyway 1, and these two partitions will be combined locally. It is not dealing anything with outside of this worker node. Okay, it's performing the combining operation internally locally, right? So because of that reason, there is no shuffle or sort is happening. So coalesce will be faster for this kind of scenario. But coalesce we can use, it works only for reducing the reducing the partitions. Even if you try to increase, it will not increase. Okay, but so what is the main why people prefer repartition over coalesce is that we are doing local combining of partitions, right? So because of that, the data skewness will be there. So we don't know why here we have 2 partitions, but now that both are combined to 1. But we don't know, right, whether which partition is full and which partition is having some space left out for performing the for performing some other transformations, right? So for that reason, it's better to analyze first about the data skewness and all that, then only perform the coalesce operation. Okay. So this is about the coalesce and repartition, and these things can be whatever we have just discussed in this video can be explained in the Spark interview questions as well, interview scenarios as well. We can consider them as scenarios, and hope this is useful to you friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.